So today is our equations mixed review. So you're going to do some writing equations, some solving equations, and even a modeling equation. So number 1 says Jonathan has $5 less than twice as much money as Juan. Which equation correctly represents the amount of money, Y, that Jonathan has if Juan has X dollars? Okay, so Jonathan has $5 less than. Okay, $5 less means I'm subtracting 5. Twice as much money. So 2 times as much money as Juan. Okay. So 2 times 1, and it says 1 is X. Okay. So 2 times 1, and it's $5 less. So I know I can eliminate. This has a positive 5. And so does this. So I'm down to B and D. So $5 less than twice as much. And we're saying that Y is Jonathan. And X is Juan. So let's make sure this reads right. So Jonathan has $5. So Jonathan has $5 less than twice as much money as Juan. All right, looks good to me. I didn't see half anywhere in this situation. So my answer is B. Okay, next problem. It says Macy's is offering 20% off all shoes. Which expression correctly represents the discount for a pair of shoes? We want C to represent the original cost. So if we want it to represent the discount, they're offering 20% off of all shoes. Okay, so the discount is 20% off the cost of the shoes, right? In this situation, you do need to remember our decimal percent conversions, right? So if it is a percent, we're starting over here by the P, and we need to get over here to the D. So we're going to go 2 places to the left to change it to a decimal. So that should help you choose the appropriate equation. All right, so number 3 says Tyler has $4.50 in the bank. Each day he adds $1.50. Which equation can Tyler use to calculate M, the amount of money he will have in the bank after D, number of days? All right, so he has $450 in the bank, okay? So that's the amount of money we're starting with, right? And it says each day. Each means what operation? Multiply. He adds, so he's putting in $1.50. We want the equation for M, the amount of money he will have in his bank after D, number of days. All right, you guys should be pressing pause and solving these on your own. So make sure we're looking at 150 per day, right? So D is the number of days, so 150 times the number of days. So knowing that, you get to eliminate, oh, look at that. We get to eliminate C and, A. Now you're down to 50-50 chance. Okay, so the next problem says Allison's uncle just gave her $50 to open a savings account. If she deposits an additional $12.50 each week, which equation can she use to calculate the amount of money, M, she will have after W weeks. All right, so her uncle gave her $50 to open it. That's how much money she's starting out her savings account with. And then she's depositing, right? Positive, an additional $12.50 each week. Which equation can be used to calculate the amount of money, M, that she'll spend after W weeks? Number 5. Which situation can be modeled by the equation y equals 2x plus 3? Okay, so this is like 4 different word problems, so make sure that you are text coding each answer choice. So A says Jennifer has 2 fidget spinners and will add, will add 3 more each week to her collection. So I should say add, Okay, so she has 2 of them and she's adding 3 each week. She's adding 3 each week. So that does not look like it matches. Now you're going to try B. Jennifer has 3 pages in her new coloring book and will color 2 more each day. So she has 3 done and is going to color 2 more each day. C says Felipe gave his sister $2 for her piggy bank. Next Saturday, he will give her 3 more. D says Sarah has completed 3 Think Through Math lessons. She will complete 2 more this weekend. Sounds like she's completed 5. I don't hear any multiplication there. All right, go ahead and solve. Okie doke. Number 6. It says which situation can be modeled by the equation y equals 1/3 x minus 4. So Juan has 3 dozen cookies and he ate 4. Well, if he has 3 dozen and a dozen is 12, so 3 times 12 is 36 cookies, but he ate 4 cookies, so he has 32 cookies. Does that look like your equation? Let's try B. Patrick makes bread every Sunday. He keeps 4 loaves for himself and divides the rest equally between his 3 neighbors. C says Lenny collects stickers from a vending machine. He has 4 already and will add 3 more each time he goes to the store. Oh, sorry, I forgot this other one. So he's making bread. He keeps 4 loaves and divides the rest equally between his 3 neighbors. All right, D, don't get fooled just because it has a 1/3. You're looking for a 1/3. It says Megan has a box of baseball cards. She gives 1/3 of her collection to her cousin and sells 4. This one's tricky. I think that we can easily get down to 2 options. Thinking B and D. But it's up to you just to decide which one is correct. All right, number 7 says which situation can be modeled by the relationship between X and Y in the table. All right, so A says the amount of money a carpenter makes if he earns $200 for X days. Okay, so it's saying that if he works 2 days times $200, he'll get $400. So that matches. But what about 4 days times the $200 per day, right, that we're looking at here? Well, he should get $800. So it says 300. So that does not match. Okay. B says the number of miles a race car has traveled after driving 100 miles per hour, and X is the number of miles. So if it's 100 miles times 2 hours, should be 200, right? Doesn't look right either. Okay, so C and D. So C says the amount of money left in a budget if the team buys X number of jackets for $50. So let's see, if I buy 2 jackets, how much should I have spent? I think 100, right? So, why do I have $400? Okay, what about D? It says the miles left on a 500-mile trip if driving X number of hours at 50 miles per hour. So if I start at 500 and I drive for 2 miles, that means I go 100 miles. So I should only have 400 left. If I travel 4 hours, 4 times 500 is 200. So 500 minus your 200 leaves you 300 miles. Looking pretty good to me. Number 8 says, based on the information in the table, which equation can be used to model the relationship between X and Y? So one way to go about it would be to choose an X value and then plug it in to each equation and see which one makes it true. So we want to plug in 9 and get 657. So if I start with A, I would say 7 times 9 is 63. Well, that is certainly not 657. So then I would go with the next one and I would plug in 9. Say 9 plus 146 is 155. That's not true either. I'm looking for 657. So finish it up by trying C and D. All right, so number 9, we have which equation best represents the relationship between X and Y in the graph. So notice these blue lines on here are your axes, but I always taught you that we were going to use our color to go down the y-axis. So now I'm turning my y-axis green, right? The y-axis goes up and down. And before I even look at the choices or what I'm looking for, right? So I want to choose an equation. I'm always going to label my y-intercept. So the y-intercept is the value of y when x is 0. So I'm going to go along this line and I'm going to stop where I meet the green line. That is going to be my y-intercept. Okay, so you're going to use that to look for your y-intercept in your equation. Our second part is always to look at your rate of change. We look at if it's going uphill or downhill. And then, of course, the third piece would be to choose a value on the line, so one of these points, and plug it in to check and make sure that we chose the right equation. Okay, so number 10 says the total number of AA batteries found in X number of packages can be represented by the equation y equals 8x. Which graph represents the relationship between X packages and Y batteries? All right, you've got this. Number 11 says Wyatt began his hike at an elevation of 12,000 feet above sea level. Throughout his hike, he descended at a rate of 1,000 feet per hour. The situation is modeled in the equation below, where x represents the number of hours, y it hiked, and y represents his elevation.